Okay, this week I want to talk a little bit about something that's near and dear to my heart, and that's designs. For someone who comes from a network engineering and network architecture background, designs were bread and butter. It's what I spent every single day doing when I wasn't troubleshooting network issues. So what I want to cover off is the purpose of a design, what a design is and what a design isn't, and then based on the purpose, what you should be doing, how detailed a design could be. So there are basically three main purposes for a design. The first purpose is to help provide a roadmap for a developer or an implementer to follow to get the outcome that you're trying to get from the piece of technology. So, for example, you need a design that shows that these three components are connected together and they talk to each other this way so that the people that configure the three components can see how they need to configure them. So that's the first reason you have a design. The second reason you have a design is that you want to provide assurance to someone who doesn't have time to come down and look at what you're doing, that you are actually following best practices, that you're following security requirements, that you're following technology roadmaps, anything to do with a design. And then the third thing, and this is the interesting one, the third design is a way that you can provide a checklist that you've done what it is that you said you were going to do. So if the design said that you were going to connect these three components together and you were going to connect them in this way, then someone can take the design and do an audit of your environment and say, yep, you actually did it. That third pattern for designs is really more of an as-built once you get done. So it's a verification check once you've completed the implementation work, and then it becomes the as-built going forward from that perspective. Now, what you should put into a design. Again, it depends on what you're trying to accomplish with the design. So there are lots of different types of designs. There are high-level architectures, there are high-level designs, there are detail-level designs. If you go into IBM Team design, you have architecture overviews, you have component models, you have system contexts. They're all functions and features within the design. But again, if you draw the design right back to its initial purpose, if you're just doing it to provide a map that shows how the different pieces work together and what configuration you need to do so you can communicate within the development team, then the level of documentation drops down. It doesn't mean you don't have to do the design. The design still has to be there. You still have to have some plan of where you're going. If instead you're doing the design for governance or to make sure that you have support or assurance from security, the detail level and the requirements for the design goes up. This is what makes typical waterfall projects very expensive on the front end side and very resource heavy on the front end side because you're not actually building the development as part of the initial design aspect. You're having to go to a level of detail within the designs that tends to be very onerous, and the likelihood of you getting over the line with those with any kind of architectural governance or security governance is much less unless you have all that detail. But the value of that design just merely to get through that governance gate is much less from a business outcome and much more from a responsibility level within it. So if the governance group trusts the developers, then the detail level that exists within the designs goes down. This becomes a trust relationship between the governance side and the development side, or the implementers on the implementation side. The only last piece is that checking to see that what you designed is what you actually delivered, and that's necessary because when you go to operations, even a DevOps model, to be able to support the environment that you've developed, you have to have some kind of as-built or design that they can use to reference back to. If there's a bug in the system and the developer that implemented isn't the one that's troubleshooting the bug, he has to be able to go back to a design and see what are the components, what are the connections that are happening from that piece of component or the configuration within it. Designs are something that a lot of times within Agile programs, you will hear people say, oh, you don't need to do designs. That's not the case. The design still needs to be done. But remember the target audience. Is the design to help you have a better implementation and make sure all the pieces fit together and so you know which direction you're going? Is the design from a trusted development project into a governance, and so you need to provide just enough information to them so that they know you're going on the correct roadmap and that you're following the right technology guidance from it? Again, as you bring those governances into the projects more, the detail level in the designs can go down. You essentially don't want to build your system before you build your system. The design shouldn't be so detailed that someone could actually copy and paste out of the design into the implementation. Otherwise, you're duplicating everything you can do. But designs are still an important part. Without a design, anything beyond a simple standalone system is going to have trouble going forward into an enterprise environment. And so you're going to need some design work. As always, let me know what you think. Designs is something that I enjoy talking about and can go into great detail on different types of designs and different value outputs for designs. Thank you very much.